Pavan Adhav, who is he will tell something about himself after a few moments, and he will be taking 3 events or 3 lectures. Every lecture comprises almost 90 to 100 minutes. And the idea is that this session should be not only the one-way communication, but two-way communication. It means during the event, you will have enough time to ask your questions and curiosity. And we are planning this event for every Saturday. So this is the first day, and next will be on the next Saturday and next Saturday. We made it intentionally because whatever you learn today, you have enough time for next 6 days to practice with resources Pawan will provide, and then you come back to next week. And if you have any questions or doubt, you can ask in the early 30 minutes of the next Saturday call. And in this way, you gain something. And from this basic kind of training or scale up, we'll keep building something in upcoming steps and upcoming days. Okay, so thank you everyone for joining. And if you are joining from Zoom, it's good. You can communicate. And if people who are joining on the LinkedIn Live, they can also ask their questions over there. Or on the event page, there is a link. They can click over here and they will directly come to here and they can interact with Pawan and do the needful steps. So Pawan, thank you very much, and over to you.
Yeah, thank you so much, Ravi. All right, good morning, guys. So thanks for coming. Okay, so first of all, I wanted to introduce myself. My name is Pawan. I'm currently working as a senior software engineer at Paramount, leading the blockchain team. So I'm having more than 8.5 years of experience, and I have been associated with Hyperledger Fabric since it was in the beta, actually 0.1 version. So when it got published, right, initially in IBM, so we were working some of the resources we were working on that, and majorly I worked on this private blockchain itself. So I would be happy to answer your question. Actually, I wanted to have this session two-way. Actually, what are the questions and all? I would highly recommend to just ask any point of time. You can interrupt me anytime and you can ask me. So that would be great. And those people who have joined from the LinkedIn live, I would recommend to join here directly on the Zoom so that they can just connect with me directly and ask their doubts, because commenting there, I will read the comments and again come here and answer it. So it's better to have directly within a small time we can manage the questions and answers actually. Okay, all right. Let's start with the session actually. So first of all, I will go through the agenda. Just give me a moment. I'm sharing my screen. Okay, you can see my screen, right?
Yes, Pawan.
All right. Okay, so throughout these three sessions, we will try to cover one use case actually, because covering the use case, it will help you to clarify a lot of doubts. So first thing, we have almost 6 to 7 sessions. First session is just a basic introduction, important prerequisite, course objective, and the development environment, what kind of environment we are going to use. So once we are done with that, like we will go through the basic concept of the Hyperledger Fabric, and this is the most important section actually for today we are going to cover. So I would highly recommend to just ask as many questions as you can. After that, once we are familiar with the basic concept of the Hyperledger Fabric, we will be going through the network creation. So that is the second step. Okay, in the third section, we will be going through the building the network, like how we can create a network, like multiple stakeholders are coming together and they decided to have some kind of policies and the set of rules, we can say, and they started the communication. But before that, what are the different steps involved to create this kind of network? Okay, so we will be covering that part here: installation, folder structure, what are the different services in the blockchain, like what are the different steps we are going to cover, what are the mandatory things, which files is important, and what is the purpose of each and every file. That will be managed in this section itself. Okay, so here we will be covering the network topology, files walkthrough. So everything will cover here in this section. Okay, once we have the network, right, So initially, when we create the network, we will do the basic transactions from the CLI itself. And once the transaction we have, it will be help us to visualize, uh, it will help us to understand actual blockchain. So for that purpose, we will be integrating this blockchain explorer, so we can visualize the blockchain, how exactly it looks like, what is the content of each transaction, what block exactly, how block looks like, what is the different endorsements and everything available inside the block, inside the transactions. And in the network topology, how these different services are there, how many chain codes are there, how many channels are there, that can be visualized using this blockchain explorer itself. Next one, once we are done with this network creation and the blockchain explorer integration, so we will be moving towards the server creation, API server. Okay, so for that again we have some sort of libraries. So we will be integrating. You will be using those libraries and integrate this API with our blockchain network. So and again, so this whole course actually I covered with. I'm going to cover with the 2.5 latest version. That is the LTS right now. For this at this time, the 2.5 is the latest version in the Hyperledger Fabric, where I will be covering there. Because why I'm mentioning explicitly that in the version 2.2 and the 2.5, there are some major changes. We need to consider it. So previously we used to have application channel and the system channel, but in the 2.5 version, the system channel they removed it because on purposefully. I will let you know how it got moved to two channel to the multiple application channel itself. Like system channel is not there, so that can be managed within the same channel itself. The policies and all. I will be covering that in the transaction flow, how the transaction flow got changed from previous to other now, and I will be explaining both of them. Another one thing, so this is the full stack application. Okay, so we will be covering front end, API, network creation, and blockchain explorer. Okay, so this is the full-fledged application. You can utilize it anywhere, and so I followed best practices at the API side, network management, and this is the single machine setup. If I am doing this on the Kubernetes, that will add additional complexity. It require additional expertise. So that's why I decided to just have these things on the single machine itself. And once you are familiar with these things, yeah, you can just replicate it on anywhere. Even you can convert this project into the Kubernetes if you're once you're familiar with that, and you can utilize the same concept, because concept would be same. It's not going to change. The way of implementation probably it may change, and the best practices and all I will try to follow most of them, and I will suggest like whenever it's necessary something needs to be done. One more thing. So S3 bucket. So this is the contract management, right? So contract management will have uh, documents actually. So I will be interlink. I mean, I will be saying like contract management, agreement management, or maybe the document management. Those are different. Those are same things only. It's not something different. So you can say this POC, whatever we are covering, it's agreement, contract, or the document management. Okay, so we are dealing with one document that could be a contract agreement, because people generally say different terms actually in their perspective of the use cases. So just consider we are doing this kind of agreement, document, and contract management. It's just a document which will go through some certain sort of processes, and user can do the different kind of operations like creation of this agreement, approving this, and all. Okay, so that part we will cover in the API side, and we will create the API for creation of this kind of topic, and we can just do the operations. Okay, so up to API side, so we will expose this API. So up to API side, you can interact with the network even from the Postman itself. But for those who are really interested, how exactly this integration works from the front end to the API and from API to the network. So these things also I'm going to cover in the next section. That is the sixth section. Okay, so we'll just create a basic front end application. It's not going to have a lot of functionality and feature, but it will have sufficient to cover all the concepts. And writing a code from the scratch, it will definitely take a lot of time. We have limited time, so that's why I already created all this codes and everything. So I will be just going through the basic flow, like how exactly this is communicating and what is the purpose of components and all. So bear with me, and again, I would highly recommend to just ask as many questions as you can, so that there would be a clarification for each of the things. Okay. On the deployment side, probably we'll just check if time permits. We'll let you know actually. So if we can manage this on actually some servers, maybe AWS machine, GCP machines, or somewhere else, and we can do the deployment of this full-fledged application. Okay. So this is the overall agenda. So anyone have any kind of question, you can ask me now on this agenda. Any question?
You can proceed, Pawan.
Yeah. Okay. All right.
No problem.
Yep. Okay. Just a moment. Okay. First of all, I was talking about the agenda, right? So in the agenda, I mentioned like what is the prerequisite. So prerequisite. So you need to understand the basic of the JavaScript. It's required actually because hello world is also sufficient. If you are familiar with any other kind of language also, that is also sufficient. You can just check the codes and everything because these things are very basic, like basic operations, we can say, creation of something and all. Okay, it's just a kind of hello world application would be sufficient to start with. Docker, if you are familiar with the Docker, that would be a great. Otherwise, you can just check some of the resources I already shared on the page. You can just go through some kind of couple of videos on the YouTube, and you will be good to start actually on this course. Basic of the JavaScript, basic of the Docker. Shell script is also required, very basic actually, where how we can run some sort of script. So those things I already shared in the resources. Next, before next section, so I would suggest you to just go through those resources and you will be able to understand the flow and the core concept. Okay, so let's go to the core concept of the hyperledger fabric. Let me just start screen sharing. Full screen actually. Yeah, okay. So first of all, talking about the blockchain, there are a lot of definition you can see on the internet, like what exactly the blockchain. It's not something public or private, but it's just basic concept actually. It's not something totally different, but the way of implementation is different over the traditional technologies. Okay, definition in the single line, I would say it's a shared distributed database. Okay, shared distributed database means it's a database which is shared across the network and it's a distributed. Okay, what are the different characteristics? There are a lot of features, and I will be talking about this blockchain. But features, okay, CFIP is consensus, provenance, immutability, and the finality. What exactly the consensus? Consensus is the process of achieving certain state of that particular data with appropriate approvals from the stakeholders into the network. So there are a lot of consensus algorithm in the blockchain. You can see in the Bitcoin we use proof of work. Okay, in the Ethereum right now they are moving to the proof of stake. There was also proof of work initially. In the Hyperledger Fabric we are using graph for this consensus algorithm to achieve the final state of that particular asset with appropriate approvals from the stakeholders into the network. Okay, so that is the consensus. Provenance, it means what? So we are adding continuously data, we are updating something, but how I can just check if someone hasn't tempered the data, and even though someone has updated the data, how we can check the history? So in the network we will have all the operations history. So I'm creating a contract today, and next week I am just renewing the contract, so the end date is getting changed, right? So in that case, on the same contract ID, I'm doing the two operations. First one is the creation, second one is the renewing. It means there would be two transactions in the chain of the block, and that history is maintained across. So anyone, any point of time, we can just check the history, and that is nothing but the provenance. We will have the history of all the records, and any stakeholder can just check it. Consensus, provenance, immutability. Immutability means you cannot temper the record. It's a temper proof. And finally is the finality. Once data is added, it cannot be reverted. If you wanted to make any kind of amendments, update, you have to make one more transaction. That is the finality. Okay, these are the major characteristic of the this blockchain network. So distributed, as I mentioned, it's distributed across the network, and the ledger is nothing but the database. Smart contract is the business logic, I would say. In private network, actually these different stakeholders or different organizations have some sort of rules in the form of policy, like who can create the contract, who can delete the renewing the contract, who can approve the contracts. Those same sort of rules we can just embed in the form of business logic and just deploy it as a smart contract. Sometimes we will be calling it the chain code actually. Chain code and smart contracts are the exactly same thing. In the public blockchain also we have the smart contract on the Ethereum, so we can deploy our own smart contract with proper business logic, creation of the tokens and all. Or in the Hyperledger Fabric, we can just write our own logic and do the needful things. Consensus, again the same thing. It's a process of achieving the final state, and consensus algorithm we are going to use in the Hyperledger Fabric is the RAF. That is the supported right now in the 2.5 version. Okay, so talking about the use case, document management is the use case we are going to cover. So it will have two different organizations. We can see organization 1 and organization 2, and we have different kind of users inside the same organization itself. Okay, financial department users are there, legal department users are there. For both of the organization, I just segregated. Again, this is just up to you, like how you wanted to design. But for covering some of the concept, I deliberately segregated this user on the basis of a department, financial department, legal department. Okay, and what they can do, someone can create the agreement. So all the users require approvals actually in the all the users need to approve the contract actually to fulfill it. So it's just a simple process. Some user will create, some other user will approve it, and we can see directly actually the history and everything, how approvals are getting added, um, how contracts is getting updated, and so all these things we are going to cover. Okay, so this is the main use case we are going to cover. And the asset is nothing but, I will just go through the basic of the asset later in the next slide. But agreement is the asset right now, and we'll be doing the operations on the agreement is nothing but just kind of data which will represent the contractual rules actually between different stakeholders. Okay, so this is the POC theme. Okay, before moving to the POC, I wanted to let you know like why Hyperledger Fabric only, not why not other things. See, so these different organizations are really conservative to sharing the data with the others. In the public blockchain, anyone can do the operations, right? There is no restrictions. But these are the confidential classified data for them, like price and everything with the stakeholders. So that's why they require this network to be a private or limited to some certain stakeholder itself. So for that purpose, we are using the Hyperledger Fabric, because Hyperledger Fabric provide a flexibility to have this network permission plus private. Permission means what? Only authorized entities are allowed to interact with the network. Like there are two organizations, only user of these two organizations can interact with each other using this medium actually. So that's why we will be using the Hyperledger Fabric for implementing this POC. And it's a private actually. Private, it means even within the blockchain network itself, we can maintain the privacy with different steps. I will cover that private, how we can maintain the privacy within the network. Maybe in upcoming slides, we have that dedicated section. Shared ledger, smart contract, and the privacy and the consensus. These are the different features these blockchains are providing. And even Hyperledger Fabric is not something different; it's also a blockchain. So we'll be having these kind of features and utilizing the same things. Okay, talking about the Fabric model will have different kind of components actually. Concept and the component, I would say. Asset, ledger, identity. So these are the most important things we'll be covering. Again, so in the network component, we'll have some different kind of components like organization, PS, orderer, channel, and Fabric certificate authority. Okay, now for explanation of this different thing, I will taking one example. Okay, there are three organizations. Just consider it's little different than what POC we are going to cover, but it's totally I'm trying to correlate with the same POC. IBM, Lenovo, and Dell. These are the three different companies, and they wanted to have a communication in the form of these contracts. So IBM is importing hardware like maybe laptop from the Lenovo and some desktop from the Dell. Okay, so these are the different business they are doing actually with each other. So for them right now, they decided come together and they wanted to implement this use case using Hyperledger Fabric. So in that case, they will come together, will set some sort of rules. who can do what and everything. Okay, so for that purpose, they will be doing this operation with IBM. This IBM and sorry, this Lenovo and the Dell, both of the organization, they are going to have a transactional communication with these different this IBM organizations, and for that purpose, we'll require these different components. Organization is just nothing but the logical segregation. It's not representing any kind of service. It's just a logical combination of the other components. I will show you how exactly organization looks like, but it's just a logical component, we can say. Next one is the peer. Okay, peer is the actual service which will be running on the behalf of the organization. It is representing the organization actually, and peer will hold a smart contract and the ledger. Okay, so smart contract is the business logic, ledger is the database. So peer is the most important component into the blockchain network, into the hyperledger fabric. Next one is the orderer. Okay, orderer is one of the component which is responsible for creation of the block and broadcasting to the all the relevant participant into the network. And this orderer is using some kind of consensus mechanism to maintaining or replicating the state of that particular data across the different other orderer into the network. And here, one of the most important steps in achieving the consensus is the hyperledger fabric as well. When we are talking about the three-phase commit, one of the phase is ordering, and I will be covering. So when we go through the three-phase commit, how we can achieve the consensus into the hyperledger fabric. Channel is the medium. Medium is nothing but like they decided to have a communication with each other, and they require some kind of medium to have a communication, right? So for that purpose, we'll be using a channel to communicate between these different stakeholders. Fabric certificate authority. Certificate authority is nothing but one authority which is responsible for issuing the certificate. Okay, these organization come together, but how they can communicate with each other, how the data will get validated, they require some kind of actor, right? Actor in the sense users actually. So this user will be doing this operation, but how they will do, how they get identified. So for this user, we record the certificate public and the private key. The certificate authority is responsible for getting those kind of crypto material for the users, all the participant into the network, user and the peers. Peer is also one of the participant. Orderer is also one of the participant, and that's why we require certificates. And the certificate authority is responsible for that. MSP, that is the membership service provider. So MSP is nothing but just kind of service. It's not any physical service, but it's just a kind of concept who can do what. This kind of set of policies can be embedded and they can be validated against this MSP of that organization. Okay. Next one is the transaction flow consensus smart contract. So these things we are going to cover when we start actually implementation of the our network. Okay. On this technology stack, actually, in the document management or the agreement management, we will have React.js for the front end, Node.js for the writing API, Hyperledger Fabric for the blockchain network. Again, we are going to integrate the Explorer for visualizing the blockchain on the behalf of one of the organization. So MongoDB, we are storing these credentials actually, this username and the password. Why we are doing that right now? Because the user is not enough mature to handle this kind of crypto material, public key and the private key. Still, you can do it if you wanted to, but we are storing their crypto material at the API side itself, and we will be giving this. We will be giving the flexibility to use the username and the password, and they can just use the username and password and interact with the network. So, because for that particular username, we will be having the crypto material at the Node.js, and using this crypto material, we will be doing this operation with the Hyperledger Fabric directly. This is the technology stacks we will be covering. Talking about the asset. Asset, as I already mentioned, it's nothing but tangible. Anything, it could be anything tangible or intangible. So in the agreement management, our asset is the agreement where we will be storing the information like first party, second party, like other documents, how the documents are getting stored. There are a lot of information, right? Here on the screen, we can see car is the asset and it's having different kind of attributes, color, make, model, owner. So, so you, as per your use case, you can store anything in the form of asset. So when you're talking about the trade finance, so trade operations, you can just do it like creating of shipments and all. In the supply chain, you can just do the transaction, lot creations and everything. So that could be embedded in the form of asset. You can just store it. Actually, this Fabric don't care like what you are storing. It just consider key and the value. The value could be anything. It's a JSON object, or it's a binary form, binary form of data, or anything else as well. That's perfectly up to us to decide on that. Okay. So asset is nothing but just kind of tangible or intangible thing which we wanted to store onto the blockchain. Next one is the ledger. Okay. As I mentioned, peer is the most important component. So it will have the smart contract at the ledger, and ledger is nothing but the database. So in the Hyperledger Fabric, we have two part in the ledger. First one is the current state database, and next one is the chain of the blocks. That is the actual blockchain. So why we have two different things? So again, we'll take the same example. I am creating one agreement, and after 1 week, I renewed it. Okay, there would be two transactions, right? In the current state database, we will have latest value of that particular agreement. The latest value is updated renewal date, and chain of the block will have both of the transaction. First one is the creation of the agreement. Second one is the updation of the block updation of the date actually, because we have renewed it, right? So that's why we will be storing both of the states. First is the current state database, second is the chain of the block. And in the current state database, we will have latest value. And in the chain of the block, we will have actually whole history of the chain. How many, even though we have made 100 transactions for that particular agreement, we will have 100 records here. And in the current state database, we will have the always latest value. What is the latest transactions we made against that agreement? Okay. So sometimes we call as the world state, current state, latest state. So those are exactly same. And in the Hyperledger Fabric, we have a flexibility to use current state database as the cows DB as well as the level DB. These two options we have. Okay, let's again talk about the same thing: ledger, world state, and the blockchain. So in the latest, so in the current state database in the world state, let's consider we have this key value pair. Key one, I am putting some ABC as the value. Key two is the PQR. Key three is the XYZ. Okay. So though this current state database is the version. So initially when we create any kind of key value pair, right, it will be version as a V0. So next slide we will just consider to update one value. Key three is getting replaced with XYZ to SSS. Okay. Now the current state database will have only this value, but it will be version as a V1. Previously it was version V0. So in this way, the current state database will maintain the latest value of that particular asset. Okay. On the blockchain side, like these will be the block structure actually we'll have. These blocks will be interlinked with each other. Block 0, 1, 2, 3. And inside the block, we will have these transactions. T1, T2, T3, T4. Again, this configuration is customizable. You can decide like what kind of operations, what kind of configuration is suitable for your use case. So you can use this. Inside the block we'll have the transactions, and at the bottom of the block we'll have the metadata. Okay, this is the chain of the block. Let's talk about the single block. So at the top of the block we'll have a header, right? Inside the header we'll have the block number, current block hash, and the previous block hash. So these blocks are interlinked with each other using this cryptographic hash actually, because previous block hash is getting used to calculate the current block hash. So that's why they are interlinked with each other. Okay, so at the header we'll have this information of the block. At the bottom we'll have metadata, and in between we will have a data in the form of transactions T1, T2, I mean T5, T6, T7. It could be anything. Okay, let's talk about the transactions. Single transaction. What kind of transactions we will have? So again, at the top we will have headers for the transactions. We will have the signature, like who has created the transactions. So I, as a user of the one of the organization, I created the transactions. I will have, while creating the signed proposal, I will sign these transactions, and that is the signature. Okay, we will have proposal response, and the endorsements. So don't worry on these different kind of terms right now. So those are the concept I will be covering, like what kind of signature we will have, how it get validated against the transactions. It's what exactly proposal contain inside, what is the proposal response actually, and finally the endorsement. So as I mentioned, peer have superpower to endorse a transaction because they will have the smart contract. So once they endorse, they will have this endorsement in the form of signature itself. So it's kind of additional approvals we can say from the organization, like before committing the data. before adding data, peers need to endorse the transaction as per the policy we define while creating the network. Okay, so this is the transaction structure. Okay, next one is the identity. So right now we are using as the PKI. PKI is a public infrastructure. It's nothing but the general concept we are utilizing since lot of decades. So when we hit any kind of domain, google.com, which is secure, first thing generally it happens, it do the handshake with this server, and this server will send this certificate. The certificate is nothing but the digital certificate itself. Yeah, X509 standard certificate we are going to use, and it's having other components, public in the private key, certificate authority, and the certificate revocation list. So we'll be utilizing this PKI into the Hyperledger fabric to have the certificate public and the private key. For the security purpose, we'll be using this, and user will use this public key, private key for signing the certificate, so for signing the transactions and everything. Okay. Certificate, this is the standard certificate format actually. So let's consider I, as a user, I wanted to get a certificate from the organization. How I can get it? There are two steps actually. First one is the registration. Second one is the enrollment. Okay. So this is the permission plus private network. Anyone cannot directly get the certificate. Admin of that certificate. Okay, let me just show you that step as well. Okay. All right, you can see here. Registration and enrollment. These are the two steps which are required actually. So registration means what? Admin will say certificate authority, like, yeah, this is the valid user, just register him. And once he registered, he will get a secret, and this admin user can give this secret to the final user, and final user using this secret can enroll. So in during this enrollment process, he will get the certificate. And during this enrollment, this user will first of all create the public key and the private key. He will put that public and the private key with himself itself, because it's a highly confidential data, private key especially. Public is shareable, but we should never share this private key with anyone. So what this user will do, he will create one public and the private key pair, and he will sign this EC what exactly CSR, certificate signing request, and he will enclose this secret and say certificate authority, I want certificate. So certificate authority validate this data and send back the certificate to the user. And this is the process of getting the certificate for any kind of user. Okay. So when this user requests for the certificate from the certificate authority, what exactly it happens under the hood? I will just explain in 1 minute. So certificate authority, once they get CSR, certificate signing request, so we'll get this, I mean the certificate authority will get this information, so this information, user's identity information, its public key and the certificate authority information, they put at the top of the certificate. And what certificate authority does, he create hash of that information, above information, encrypt this hash with the private key, because certificate authority is creating this certificate. He create hash of the above information and put it as a this hash get converted by, I mean, encryption at the bottom of the certificate. This encrypted data will put as a digital signature, and this signature, once this certificate creation have done, the certificate sent to the user. Now let's consider I'm claiming this certificate is valid, but how anyone can validate? Again, they can just do the same thing. If someone wanted to validate certificate at the from the top information, they can just create a hash of the information. Again, digital signature can be decrypted using the public of the certificate authority, and that information is available in the certificate itself. If these two hashes are equal, it means data is not tempered actually in the certificate. If I, as a validator, if I trust this certificate authority, I can say this is the valid certificate. Okay, and this is the validation process happens throughout everywhere. It's not something in the Hyperledger fabric, but everywhere. I would say here, this is the secure, right? The connection is secure. How exactly it's claiming connection is secure? browser itself have certificate authority list, valid certificate authority list, and it is just validating against those certificate authority. So I was talking about the information, right? At the top of the certificate will have information issued to, issued by. This is the certificate authority information. GTS CA 1C3. Google Trust Services. This is the certificate authority. Validity is like it's going to expire 26 March 2024. Okay. And digital fingerprint I was talking about, right? Digital signature. This is the signature at the bottom of this certificate. Is SHA-256. If you wanted to have more information, you can just get a detail as well. This is the same certificate, the standard we are going to use in Hyperledger Fabric as well. Okay. Any question till now? Okay. All right. Okay. Yeah. So this is all about the certificate, and we are heavily using this certificate in Hyperledger Fabric because Fabric don't understand username and the password. They just interact with each other using this certificate public key and a private key. On every step, the validation happens of the signature, and signature get created using the private key. Okay. Next one, TLS communication. Okay. So these are the different. This is a decentralized and distributed system, right? So every organization should host their own services on their own infrastructure. That is the ideal case, and people generally prefer to have it because when we are talking about the decentralized and distributed, and if we're having on the single machine, so it's kind of beating the purpose of having this blockchain itself, right? Because if someone has access to all the blockchain network, they can do anything with that. So that's why generally people prefer to have the separate actually. But on the demonstration purpose, I will be doing on a single machine. It will add additional complexity if you're doing on the separate machines, like organization one on the single machine, organization two on the different machines and all. Okay. So when the services are different, maybe on the single machine or on the different machine, they need to have a communication, right? Because it's the peer-to-peer communication they're going to do. And that's why we need to have a secure communication. So these services will be having the TLS communication with each other. This is transport layer security they will be doing. And in the transport layer security, how exactly it happens, I will show you. Client generally, first of all, do the handshake signal with the server. Server will say hello again and send the certificate, server certificate. The client will validate the certificate, and if the certificate is valid, then what they can do, they will just exchange one some kind of symmetric key with other services. This client will create one randomly generated key, that symmetric key, and send this key to the TLS server. Again, while sending this, he will encrypt with the public key of the certificate of the server. So server gets once they get this, server can just decrypt with the private key because only server will have the private key, and in this way, this key will get exchanged with each other. Once they have the key on this planet, they will be the only two entity who has that randomly generated key. So using this key, they can just initiate the transaction while sending any information server to client. He will encrypt with the same key, and the client already have that key. They can decrypt it. So in this way, this secure communication will happen. So there is a one-way communication and two-way communication, a two-way secure communication. So this is the one way initially. If they wanted to have a two-way, again, client will also send his own certificate with server, and again the certificate validation will happen. This is the two-way communication generally happen, and this is the TLS communication we can consider. So we have a different components, as I already mentioned. This organization will have peer, and peer inside will have the ledger. Each organization will have the certificate authority. These are the different components. Order organization also will have some kind of ordering services, and these are the different network components. So inside the organization, let's talk about, I wanted to have one organization on my network. I mean, I am one of the participant into the network and I wanted to have, so what kind of different services we need to have it? Okay, first one is the peers. I can have any number of peers, it's totally up to me. And for high availability, I can make maybe two or more than two peers actually. If one of the service goes down, still other services will be up and running for serving, like doing the endorsements and everything. Okay, so it is recommended to have at least two peers. or maybe more than that. Again, it's up to your business use case. You can decide on that. So peer will have the smart contract and the ledger. Ledger will have two things: current state database and the chain smart contract. Sorry, ledger will have current state database and the chain of the block, and the smart contract will have the business logic. The organization can have any number of users, n number of users, and organization will have their own certificate authority for distributing the certificate to all the participant. Who are the participant? User are the participant, peer are the participant. Okay, so this is the organization structure. So what is the peer? Peer is most important component, as I already mentioned. So it can have different kind of ledger, different kind of smart contract as well. Peer is one service which is going to hold smart contract at the ledger, you can say. And again, IBM IBM is a part of two channel, right? Two medium with Dell and Lenovo. So for that purpose, they can have different smart contract. They have different contract agreement itself. Like for Lenovo, it's different. For Dell, is different. They can have different smart contract itself on their own peer. They can have different ledger as well. Because if we are considering the channel is different, then the ledger would be always different. Because ledger is representing the data executed by that particular smart contract itself. So this is all about the peer. Okay. We can see here in the diagram we have four different organization 1, 2, 3, 4. I'm just, again, this is just for the understanding purpose, so I'm just trying to cover different scenarios. Organization 1 have two peer 1 and peer 2. Those are the services. Organization 2 have 3 peer. Organization 4 have, so organization 3 have 2 peer. Organization 4 have 1 peer. So each organization have different peer, right? Organization 1 and 3 have 2 peers each. I wanted to create one medium, a communication channel. Okay, so here we have a channel, and what we decided, this organization decided, this organization 1 decided only peer 1 will be part of this channel. I can decide, actually, it's totally up to me. Peer 2 could be part of other channel as well, right? Because they have different medium itself to communicate with other organization. But for time being, peer 1 is the part of channel 1. Peer 3 and peer 5 of this organization 2 are part of same channel. From organization 3 peer 7, and from organization 4 peer 8. So these are the different scenarios we can have. You have to design as per your use case. Okay, so for our use case, document management, we have just a plain configuration. Two organization who all both of the organization have one peer each, and they both of them are part of the channel. It's just a very straightforward. Okay, so there are different peer roles actually. So I will cover this part, different peer roles, during the transaction flow. When we do the transactions, I will show you. So there are four roles of the peers: endorsing peer, committing peer, anchor peer, and the leader peer. So it's not something different peer, but it's just the role of that peer. That particular time, peer can play any one of the role. I will show you that part when we're talking with the transactions. Okay. Okay, talking about the channel. So why channel is required? It's just a medium to have a communication. So it maintains the privacy and confidentiality between the network itself. As Fabric is a permission plus private network, this privacy is already maintained. At the first layer, these only authorized entities are allowed to communicate with each other, right? But within the network, as I mentioned one use case, IBM, Lenovo, and Dell, they wanted to maintain the confidentiality. This IBM and Lenovo, whatever data they are doing the communication, it should not be disclosed to the Dell. So that's why we will have different two mediums to have a communication. For that purpose, we can use this channel, and it provides the confidentiality and the privacy actually. Okay, one channel can have multiple business logic or smart contract chain code. So that's why on the single channel we can have different kind of business logic. So we can do it totally as per your business requirement. So other information is there. We can have multiple channel actually. One peer can join multiple channel, or one peer can be part of multiple channel. Okay. In the Hyperledger Fabric 2.5, we have only one kind of this channel. Okay, application channel, and we can have n number of application channel. But system, previously we used to have the system channel in 2.2 or earlier. There we used to store the consortium information. Consortium information means what? Who are part of the network, how many organizations are there, which organization is allowed to create a channel and all. We used to store that information in the consortium channel, that is the system channel. But right now in the 2.5 and the latest version, so we do not have that concept. We have only application channel and we are embedding everything inside the application channel itself. Okay, ordering. So orderers are responsible for creation of the block. When there is a process, when they get a transaction, they just chronologically uh, collect the transactions and create a block and broadcast that block to the all the relevant participant or the peer. I'm saying. Okay. Implementation, we have different type. We had actually previously. Now we officially Raft is only supported. Kafka and Solo are deprecated. PBFT, they are going to support BFT or PBFT, practical Byzantine fault tolerance. They are going to support officially in the 3.0. That will be LTS one of them. But right now it is in beta. If you wanted to test it, you can test it actually in the 2.5 latest version. It's in the beta actually. Okay, this is the orderer. Certificate authority, as I already mentioned, public key, private key, and they will just issue the certificate to the participant. On the transaction flow, I wanted to cover it, but maybe what we can do, we'll take a quick 5 minute break actually, and what are the questions you have, we can just discuss on that part for the 5 minute again, and we can continue the same session. Guys, can you hear me?
Yes, Pavan, we can hear you.
Okay, let's
And
take.
there is
Yeah,
a
please.
there is a question on the chat
Okay,
from Ram.
okay, I'm just taking it. Yes, yes, okay. It's totally you. See, any number of admin user you can create actually. So certificate authority admin, it means nothing but the organization admin only. And we can have any number of admin. Again, you can just segregate that different admin responsibility as well. Like you can just tag some other attributes within the certificate, admin of this department, admin of this, that department. It's totally up to you. But yeah, you can have any number of admin user. Is there any chance of single point of failure if the central certificate central authority CA is handling certificate in the organization? Okay, a certificate authority right now we can have one, and even for failure purpose, like you can consider multiple as well. But yeah, there is a chance. If you wanted to create a new user and certificate authority is down, so you won't be able to do it. So for that purpose, you can have multiple instances of the same certificate authority. There is one possibility. But if you have already created the certificate and all, you don't require certificate authority at all after that. Like until unless you require new users, I mean new user enrollment and registration. Okay, resources. Ravi, I think we already shared the link of these resources, right?
Yes, we have. And after this call, I will share it on the to all the participants, and I will share that on the LinkedIn page as well.
Okay, okay, all right. And what is the capacity cap of number of the channel being made? Okay, so when we're talking about a lot of channels, right? It add lot of administrative overhead. So people has tested like 50 to 100 channels or 200 channels as well with 100 organization. But um, if you have such kind of requirement, so you have to test it before that, because it add administrative overhead. They continuously communicating with each other. They send the heartbeat messages and everything. So on the channel basis. So you have to be very careful while doing lot of channels and all. If you can manage logical segregation at the application layer and utilize this hyperledger fabric with minimal number of channel, that would be great. Again, it's kind of controversial topic. Like maybe I am saying, as per my opinion, like we can have any number of channels. Someone will say like it should have very minimal if it is possible. So it's up to your use case, like how many you wanted to have. But people have tested like hundred of channels on the network. Isn't the root CA kept offline? Yeah, it's the organization's responsibility, right? So organization will do the needful things, whether they wanted to have the certificate authority services offline and all. So if from the front end user is initiating the registrations and all, then definitely on the behalf of those user, you have to do manually in case if you are putting this certificate authority offline. It's totally up to you. Okay, you will get the recording of the sessions like Ravi will share on the Hyperledger India chapter itself. So you can just get that recording from there.
Yes, the resources list and the recordings we will keep posting on both Hyperledger India chapter LinkedIn channel, and on the Hyperledger Foundation we have a YouTube channel, and inside there is a playlist called Hyperledger India chapter. So there you will be able to see this recording start to end. Not only this session 1, but session 2 and session 3 as well.
Okay, I'm sharing the resource link actually. You will get a idea as well, like what we are going to cover and everything. Shall I share Ravi here?
Okay, yes.
We have a limited time, so probably so hands-on we are not going to do here directly. So we will be I will be doing these things in front of you, and you after session you have to just go through it and just try to do the same things. You will be able. This is theoretical part. Just try to understand, because if you understand this, then you can create any kind of the project around the Hyperledger Fabric. Okay, let's take a break for 5 minutes then, and let's come back.
Okay. So I'm still here. If any one of you have any question related with Hyperledger India chapter activities or other resources, how you would like to participate, and Hyperledger Foundation offer few certification for this. I mean, not the student only, but in general. Uh, any relevant question about Hyperledger Foundation, you can ask me over here. Um, are the student ambassador programs still open? Yes, that program is still open. To be frank, there is no set deadline for that particular part. So Hyperledger India chapter, kind of, we have uh, started Hyperledger India chapter student society, and inside society we have this Hyperledger student ambassador. The idea of ambassador is to be kind of, let's say, front face at any particular institute for the institute community, and how that person can do this activity by initiating a Hyperledger India chapter student community at your campus. Like you have IEEE student chapter or other societies student chapters like that. Where can I apply from? Okay, so I am going to share my screen and then I'll share you the details. It's good time to. Just wait a moment. Okay, I hope you are able to see my screen. So this is Hyperlaser India regional chapter wiki page. So if you are aware about wiki page or this particular component, then it's good. If not, then it's for those people. So we are open source community. It means every information, whether it's meeting, any event, they are publicly open for everybody. So on that line, Hyperledger Foundation maintain the records on this wiki pages. So the main domain is wiki.hyperledger.org. Inside that domain, we have Hyperledger India regional chapters details. So here you will see a lot of detail about all the relevant activities. So coming back to the specific questions over here. So if you would like to be a part of Hyperledger India Chapter Student Society as a student ambassador, or you would like to open it at your campus, then you just go to this link, Hyperledger India Chapter Student Society page. So this society page has different details, means what are the rules and how you can apply and what are the roles and responsibilities like that. So if you would like to start a student society at your campus, so these are the objectives, and you would like to be a student ambassador at your community, then you can uh, edit this particular page. Edit means just create your LFID. I believe if you are here, it means you have created. If not, then LFID just like sign up for wiki page or wiki.hyperledger.org, and that sign up is not only for this particular wiki page, but in general single login credential for Linux Foundation, so that you can use for other project as well. So if you log in over here and just share your interest that, okay, you would like to be a part of that thing, and then and we will reach out to you over email. Or what you can do that in this particular page here itself, here you are able to see this online meeting URL. So this is our meeting URL. Actually, what the meeting which we are joining using this same bridge. So this particular bridge is dedicated to the Hyperledger India regional chapter. So every Thursday from 3 to 4 p.m. we do the um, kind of sharing updates about the community progress and events. So you can join any of the call and then introduce yourself over there if you are new, and propose your interest, and we'll discuss something over there. And these are the two ways to do this. Okay, so there is a
Okay, all right,
question.
yeah.
Okay, Pavan, just 2 more minutes.
Yeah, please. Mhm.
Nikhil is asking how to register for Hyperledger Foundation mentorship program as a mentee. Uh, okay. Okay. So for this particular how to register for Hyperledger Foundation mentorship, this is very relevant question because every year we open Hyperledger Foundation open mentorship projects. So usually it's happen in kind of third week of March to second week of April, something for Hyperledger projects. So if we come back to how we can help you, so Hyperledger India chapter link community, we started a event called monthly huddle. It's a LinkedIn live session. So next session is scheduled for next Saturday, I believe 12 to 1. Okay, so after session 2 of this Hyperledger blockchain build scale up, you can join that call as well. And that particular call will be dedicated for how you can apply for Hyperledger Foundation mentorship and what are the do and don'ts to be successful in the project. So you can get relevant information and wait for next week, and we'll share the event or LinkedIn Live event details and links on the Hyperledger LinkedIn page. So kindly keep following over there. Okay, thank you. So Pawan, now.
Yeah, Ravi's on LinkedIn as well. We got some of the comment. I'm not able to open it. Can you just check, like, is it a questions or what?
Okay, so there was- no, there is no question.
Okay, all right. Okay, I'm just sharing my screen. Just a moment. You can see my screen, right?
Yes, we can see.
Okay, all right. Yeah, so those are the major uh, core concept, I would say. So initially, you have to be familiar with all the components and the purpose of each component, so that for creation of any kind of network, it will be very useful. Like, it's kind of just initial architecting the network. Like, some clients say, like, I want this kind of network. So this main component will be useful for useful for creating the blockchain network. So how many we require and all. So we need to think on that. Like, organize one client is saying like five. I want total. We have for total five stakeholders. And how we can just have different component, how many peers we require, what certificate authority, smart contract channels. So that things we for considering those things, we need to clear with this core concept actually. Okay, now let's go to the code base. I just shared one more video on its YouTube agenda. Previously, I launched one of the course actually, and the same course actually I'm covering here. Let's try to have full course within these three sessions as well. If we require additional session also can be done. So let's go to the code base. Okay, you can see my VS Code, right? So
Yeah.
font is fine, or shall I increase it?
Okay.
Okay. All right. Okay. So this is the folder structure. On the resource page as well, I just uploaded this full zip file. So we have everything required for this course. So let's go through the folder structure. Okay. First one, VS Code setting, just neglect it. Apache configuration. This is used for the deployment of our server. So API is, so we are covering all the API writing inside this API folder itself. Okay. Next one is the blockchain. Blockchain will have all the information related to our blockchain network, like creation of the network and the blockchain explorer. Next one is the UI. UI is required to integrate this. I mean, sorry, UI we have written in the React.js, and it's required to do the operations from the front end directly by logging into the sign in. How I mean, how our application looks like. So I will just I will just show you just a moment. I have some screenshots. Okay, you can see my screen, right? So here, so this kind of application we will be having first login screen, registration. So these things, all the I already covered it. So by just doing the operations and everything, contract management, registration, login. Once we have that, uh, even I mean registration is there. Next one, we can just create the contracts, different type of contract. This is just a sample data. So we'll have dashboard, admin, contract history, user profile if you wanted to update, and we can just add contract. We can just check different status of the contract, in progress, which are active, expiring soon, all. So these are the different things we will be fetching from the blockchain itself, and creation will happen onto the blockchain directly. So this is a new addition of the contract. So I did not consider in styling and making it like UX really good. So I'm not a front-end developer, but still managed to do these things. So bear with me. So maybe I would be happy to get contribution to make this more beautiful if you guys are interested. So admin dashboard will have all the user information. Even I can activate or deactivate user from here itself. Like activate or deactivation is nothing but user won't be able to log in into the system itself. And when you are activating, these certificates and all will get created. And this section have only admin access. Like admin, if user is admin, then only he will have access to this section admin. Okay, this is the cows database, how it will look once we have the network. We are going to go through this again, but just wanted to show the application screenshot, how exactly our application will look like. This is the asset I was talking about. So it will have different kind of fields. Department, document type, what is the document, where it is getting stored, end date, uh, first party, second party, lot of other information. We can have anything additional to this. Blockchain Explorer here, where we will be able to see different kind of blocks and everything. So dashboard will have this different UX, network blocks, transactions, chain code, and the channel. Different things we can see and visualize in the block and transactions. We'll be able to see a lot of other information. Let me show you here. Okay, this is the transaction details I was talking about, right? The transaction will get it added. How many approvals are there? Who has created? What is the chain code? What is the type of the transactions? What is the content of the transaction? Read set and the write set. So this is the all things we will be going through it. On the blockchain explorer, even we can register additional user and we just expose the UI. Okay, so this is about the application screenshots. So let's talk about the folder structure now. So folder again inside the API. So this is the folder which is responsible for creation of the API server itself. So it's having a lot of methods actually by creation of the contract, approving the contracts, getting the contracts. I will show you once we are done with this blockchain network creation. So let's focus on this blockchain network. Inside the blockchain folder, we have artifacts. Caliper is not required right now. I was having some plan, but don't worry. Just don't consider this caliper. Channel artifacts will be storing some of the artifacts inside this once we start creation of the network. The Explorer is responsible for this Explorer integration. So this folder having the code which we can run on service and visualize out the blockchain. So there are some certain script for creation of the channel and deployment of the chain code. Okay. In the artifacts again, we will have the chain code and other information like in the channel what are the policies and everything we are going to embed this information is available inside this channel. Okay, create certificate with CA. This is the folder mainly responsible for creation of the certificate for all the participant. Okay, before that, so this is the first step. Let me just check the readme if we have. Okay, we do not have details here. Okay, I will add it, no worry. So different steps actually we need to consider. First thing is the certificate authority. As per the network topology, let me show you here. Okay, so we have two organization 1 and organization 2, and one ordering organization would be there, right? It means two peer organization. This is the actually network topology we are going to cover. There are two organization, one ordering organization, and each organization we have one peer. Peer 0 is part of organization 1, and one more peer. Name is same, but these are the different services itself. Peer 0 in the organization 2. In the ordering cluster, we have three orderers actually. Okay, why we have three orderers? For making high available, even though one of the orderer goes down, our network will be up and running because majority of three is two, and that's why for high availability we have three orderer in the orderer cluster. So it's recommended to have odd number of orderers 3, 5, 7. So in case if we have 7, even though three orderer goes down, our network will be up and running without any issue because majority of the 7 is 4, and until and unless there are 4 orderers, our network will be up and running. So that's why we'll be right now for demonstrating this POC we have three orderers, one API server API server is representing both of the organization. Actually, we'll be switching the. So API server is responsible for handling API. I mean API call to both of the peer organization. So we'll be switching between the user from organization 1 and organization 2, and they can just do the operation from here by pointing their credentials to some this API server. Okay, this is the network topology we have. Okay, so as per the network topology, the first step is okay. The first step is creation of the crypto material. Okay, because crypto material is required. Okay, here these are the steps. First thing is crypto material, but for getting crypto material, we require certificate authority, right? So first thing we have to run all the certificate authority. So how many organizations are there? Three. Two peer organization, one ordering organization. This is the Docker Compose file, which is responsible for handling these services. Just a moment. Okay. First certificate authority, it's having the information. I mean, I'm using Fabric CA is the image for certificate authority, same image for all the certificate authority. This is CA org1, CA org2, and finally CA orderer. Okay, so it's having the environmental configuration, and I'm just persisting this data actually here. You can see Fabric CA. You will not have this folder initially, but once you run these services, this folder will get created here itself. I'm persisting this data on the local. I mean container name, host name is this one, and I'm considering this under this test network. Okay, some other information is there. What is the name of the certificate authority server, where it will be running? So this environmental variables are required for all the certificate authority. Name is different and exposed ports are different. You can see here. So we'll be hitting this port for getting the registration and enrollment. First thing is I will just run these services. Okay, let me just delete this itself. Okay, currently I'm inside the create certificate with CA folder. Okay, so I'm just deleting this. Okay, we do not have now. So what I will do first thing, I will run the certificate authorities. I mean for running the certificate authority, we have to run Docker Compose up in detached mode. That is a -d. So it will see initially if you do not have any kind of certificates, right? This certificate authority self signs the certificate for them, and you will be able to see their crypto material here. Order organization org1 org2, and inside this we'll have everything: CA certificate, TLS certificate, and their crypto material as well. In the these are the private keys actually, TLS and other normal certificate. So there are two type of the certificate in the hyperledger fabric. One is the enrollment certificate, second one is the TLS certificate. Enrollment certificate are used for doing the transactions, right? I am invoking the transaction. And TLS certificate are used for having the secure communication between these two different peers actually, different services we can say. So we'll have always two certificates type for peer orderers and certificate authority, but for user we will have only one, only enrollment certificate. Okay, now I can see here Docker peers, and these three services are up and running now. Okay, the certificates authorities are up and running for all the three organization. What is the next step? Creation of the crypto material. So there is a one more script here, create certificate with CA. Okay, so I am just doing the same thing as I mentioned earlier. Registration and enrollment is the process for creation of certificate. Who are the participant into the network? So let's try to go through the organization one. Okay, I just written two, three functions, and again, so you can just make it more proper as well. Let me just, okay, here create certificate for the organization one. So what we are doing, admin user will get created automatically when we run this certificate authorities command. Fabric CA server start admin and PW is the username of the default admin user of this organization, a certified authority. Okay, he is getting registered with this username and the password. So while registration process, if we are providing explicitly secret, so this can be used for the enrollment later on. But if you are not providing this secret, certificate authority will give one more secret actually. And this certificate we have to use, sorry, this secret we have to use for the enrollment. So that's why I'm just enrolling for the default admin here, Fabric CA client, which is running on the 7054, and I'm just providing the username and the password, secret actually, to the certified authority, and I'm enrolling it here. And for having the communication with certified authority, we have to provide the TLS certificate, which is available inside the Fabric CA folder. Okay, this is the enrollment. Node organization unit. Okay, in the Hyperledger Fabric, in the 1.2 and above, they introduced the node organization unit, which are responsible for doing some sort of operations, like who can do the administrative operation. Those user who has admin as the organization unit in their certificate, they can do it. Who is responsible for endorsing the peer? Those participant who has node organization unit as a peer in the certificate, so they can do the endorsement. Who can do the right transaction invocation? So these all the things can be covered inside the node organization unit. And while enrolling this certificate, we have to provide like what kind of node organization unit we are considering. There are four type of the node organization unit: client, peer, admin, and orderer. So this will get added into the certificate itself. And while doing the verification, they will just check like whether this participant has orderer as the node organization unit for doing creation of the block and all, right? So that's why they introduced the node organization unit, and we'll be using these same things. So right now you can see registration of the peer. I'm just doing the registration of this peer. I'm providing the secrets and everything here. This is the command Fabric CA client. Okay. For prerequisite and installation, I did not cover that part yet. I am just giving a brief on the folder structure. And in the next section, we are going to cover again from the prerequisite. But in the resources, I have already given the prerequisite one document. You have to just follow that and just install everything. And the agenda video which I provided on the YouTube, right? So there I covered actually some of the core concept, and meanwhile you can just go through it if you get a time. The prerequisite we will be doing. So why I'm mentioning prerequisite is Fabric CA client initially we will not have. Once you done that prerequisite installation, in the Fabric sample folder it will get added, and we have to export that path, and this binary will be available for use. If you are not getting unknown Fabric CA client command something, then you have to do that prerequisite installation. In the next section probably I will try to cover that part, and I will let you know how to export it. So there are multiple binaries. Fabric CS client is one of the binary we can say. So we are doing registration with the certified authority of the organization one. ID with ID name is peer0. Secret I'm providing peer0 PW. So this is the node organization unit I was talking about. ID.peer. I'm providing the TLS certificate of the certified authority. Once I'm done with the registration, see this all the operations I'm doing on the behalf of admin of that organization, because I'm running this script right now. All these peer0 users registration of the admin user will get covered here itself. And even I am doing the enrollment on the behalf of this user. Registration is the first process, enrollment is the second process, and we will get the certificate. So for TLS certificate also we have to do peer required a TLS certificate, right? So for that purpose we need to do the operations, and these are the script which is covering creation of the enrollment certificate as well as the TLS certificate for the users. Okay, so this is the script actually for organization one. The same we have for the organization two, ordering organization, and some other information I'm doing. So I will let you know when we are dealing with the API server. Okay, so I'm just running it now. Just a moment. Okay, just I'm running this script. Create certificate with CA. So it will just create one crypto config folder. I'm just deleting existing. And at the bottom, all the methods are uncommented. So from top to bottom, all the function will get executed. I'm just running it now. Our certificate authority already up and running. Just check if you are getting any error or something. You have to validate like what's wrong there. Okay. All right. All the certificate got created. There is no error as well. You can see, and this is a one-time activity. You don't need to do it again and again. Once you have the certificate, this network creation, channel creations, you can do any number of times. So here, crypto config, this folder got created. Okay. So let me just show you one of the organization, peer organization, organization1.exam, example.com. You can just change the naming convention. So from where we are using this, I will let you know. But yeah, so in the organization one, we have only one peer, right? Inside the one peer, peer is your organization one. There would be MSP and the TLS certificate. MSP is responsible for doing signature, like endorsing the transactions, and the TLS certificate are responsible for doing the secure communication with the other peer and other services in the network. Okay, MSP, this key store, it will have different same folder structure. The important thing is key store and the signed certificate. Signed certificate, this is the enrollment certificate for this peer, and we can, let me just show you and decode this. Just open it. Okay, this is the command for opening the certificate test. No, it's not a test. Okay, set.pm. Why I wanted to show this, because you can see one of the node organization unit is a peer here, which is mentioned inside this certificate actually. So, and if this user is doing invocation of the transaction, he is not allowed because his node organization unit is not responsible for doing these things. When I'm creating the configuration block, again I will show you there like how it's responsible for doing administrative endorsements of the transactions and all. Okay. A key store will have actually the private key, which is responsible for signing the transactions. And okay, so this is the private key. In the MSP, we have key store and signed certificate. And those are the important thing. Even TLS certificate as well will have the same thing, key store and the signed certificate. But these certificates are getting used for the TLS communication. Each organization will have this kind of folder structure. Now we have completed this through two steps, right? Create crypto material and certificate authority. What is the next step? Creating the artifacts. Now these organizations are done with the first two steps. Now it's time to decide the rules, like who can do what, and right. So for that purpose, we have crypto config folder, a crypto config file. This config.tx.yaml. Okay, so inside this config.tx.yaml file, we have mentioned everything. These are the policies and everything mentioned for these two organization. We can see order organization. So name is, we are pointing the MSP directory here, which we just created, crypto config folder, right? Organization MSP. We have to provide the MSP because MSP, as I mentioned, is a membership service provider. All this certificate will get validated against the certificate authority certificate, and this MSP will have the certificate authority certificate only, and we are going to include that only inside this configuration block. So these are the policy: reader, writer, and admin for this organization, order organization, who can read, who can write, who can do the administrative operation. So you can say member is one more node organization unit, which is not actually node organization unit, but it is representing any kind of node organization unit: client, admin, orderer, and the peer. Okay, for orderer we have this one. For organization, again, we are pointing to the MSP of the organization, that is member service provider, who can read the transaction, who can read the data, and anyone who has admin as a node or organization unit in their certificate. Peer also required to read, because while doing the endorsement, they need to read the data from the current state database. And the clients are also responsible for reading the data. Who are writer, admin, and the client. Peer and the orderer, they are not responsible for creation of the any data, right? Only admin users are responsible. So it could be admin or the client. Admin is responsible for doing the administrative operation actually, just like creation of the channels and all. Who is responsible for the endorsing the transaction? Who is having peer as a node organization unit their certificate? I just showed, right? And we just decoded the certificate here. And this certificate can be used for endorsing the transactions actually. Okay. Custom policy, you can also do it again. It's up to you, but it's little complex way, I would say. For organization 2 also we have the same thing. We have a channel capabilities. So channel capabilities purposes. So let's consider you are creating a network with other organization. There is a possibility, right? They are using the wrong binary. I'm using 2.5 and they're using 2.2. There is a mismatch. So this capability will handle that scenario. They will help all the organization to come with some sort of particular binary. Like if they are using 2.5, the compatibility of the 2.5 is 2.4 maybe or 2.6. So it will allow only those binary, not 2.2, because there is a configuration changes in the structure of the blocks or transactions. So this will handle using these capabilities. Application defaults, these are the access control list. Like we can just define who can do what, like lifecycle chain code. There are a lot of things actually. We'll cover it this later in the ACL part. Organization level policy. Now we have this. Okay, there are two type of the policy. First one is the signature policy, which actually says like I want this kind of identity. So here you can see, right, admin who can do administrative operation. I want admin of organization, only admin is allowed. But in the implicit meta policy, they say any reader, okay, in the organization who can read it, anyone who is the reader. So it could be from organization 1, organization 2, organization 3, something like that. Okay, life cycle endorsement, admin. So again, majority of the admin. So these are the administrative operation can be done by the majority of the admin in the organization structure. Ordering configuration we have here again at the bottom, and channel rules we can also set. And finally we have this profile. We will be using this profile indirectly. It's pointing to the top information only. Channel defaults defined at the top, order defaults are defined at the top, and we are overriding that configuration because we have three orders here, and these are the three ordering order addresses. And finally in the application information we have these two organization which we are going to enclose, and this is the profile we are going to use. Here is a file create artifact.sh. Config txgen is one more binary we are going to use, and it will come with that fabric sample. Actually, when we do the prerequisite installation, we'll be able to get this binary. So using this profile, which is available in this config txt.yaml file, we are creating channel name. This is the channel name, my channel, and we are creating the block inside the channel artifact class channel name underscore dot block. Okay, so one block will get created here. Okay, here we already have this. Let me just delete it. Okay, so I'm just running it now. Okay, here it's little outside. Inside the channel it is there. Dot slash create artifacts. Okay, I'm just creating it. We can see this my channel dot blog got created, and it's having all the information. It's in the different format actually, protocol format, if I'm not wrong. So you won't be able to read directly, but some information still you can just check it. So it's in the protocol format. If you wanted to make it readable JSON format, you have to use some binary and just decode this data. But later I will show you like what exactly content inside this, because we have dedicated API to get this data as well, configuration block and all. Okay, now we have completed third step as well, create artifacts. We have now policy defined and set of rules as well. So we can use this, we can utilize these artifacts and create all the services. Okay, what are the services right now we have? We already created certificate authority, and inside that we have one dedicated Docker compose.yaml file where we define all the peer services, right? For each organization, we have one peer. In the ordering cluster, we have three orderer. Okay, just I'm minimizing here. Here, orderer.example.com, three orderers are there. So we require these services, right? So I am just providing the same thing. Some environmental variables are required, TLS communication and the cluster communication if they want. They will use actually. And so their crypto material also we have to provide, right? Because orderer will, when they're creating the block, they need to their crypto material. And if they wanted to communicate with each other, they require TLS certificate. So whatever the certificate we created in the previous step, we have to map this certificate inside this orderer, and we are pointing the same thing. So we have to expose this port, so 7050 which is running internally, and outside also 7050 this orderer. For the next orderer also, internally it is running on the 7050, but export externally on this machine, we can have only one service on single port. That's why we have to use different port for different services. So these are the different orderers we have. And CouchDB we have two, actually two are required for PS0 organization 1, PS0 organization 2. One is redundant, just don't worry. PS service again will have other information. So this is the main service actually I was talking, right? It is representing the organization. It's managed the smart contract as well as the ledger. So it's having the different environmental variable, and here I am just providing which current state database I wanted to use, CouchDB, and where it is running 5984, which is running CouchDB zero service, this one. And for peer zero organization 2 also we have the same configuration, only difference is they are pointing to their own crypto material. Okay, let's run these services now, which is available in the artifacts. Okay, you can see all the services are getting up actually. CouchDB 0, peer 0, org1, org2, orderer, 2 CouchDB. Now if you see Docker PS, you will be able to see a lot of services actually. All the peer, all the certificate authority. Just a moment. Okay, all right. All the peer, all the certificate authority and all, we will be able to see it. Now, what is the next step as per the criteria we define? We have all the running services now. These organizations are already up and running. Now they can create the channel. They have decided the configuration. They did not create any medium. They just decide the configuration. Using the same configuration, we can just create the channel. So creation of the channel is available here. Okay, so outside the channel, there is a script folder. Okay, so create channel is the file which is responsible for creating the medium. Again, you can see here create channel and the join channel. Okay, so initially we have creation of the channel. So this channel creation, we have to know ordering service. OSN is the ordering service node admin. This is one more binary. It got introduced in the latest version 2.4 if I'm not wrong, 2.3, and 2.5 is the latest. So I'm just mentioning, just join this channel actually, which we just created. So orderer will know using these three things. There are three orderers. So orderer first, orderer two, orderer three. Okay. So using this, we are just letting know order just join this channel. So this all, in the latest version, they made this configuration. Previously, we used to have this information in the consortium. Now it is available here itself. These three things are responsible for creating the channel. And once the channel is created, peer can join the channel now from organization one and organization two. So these are the script actually. I'm just running it now. And don't worry if you are getting any kind of channel or something, any error or something, just don't worry. The channel is already joined. Okay, let me just check. Maybe our network is already. I'm just verifying it. See, channel creation, deployment, cross services down and up, you can do any number of time. Only certificate authority is the one-time activity. Even you can do it multiple time as well, but it's not necessary. It's redundant. Okay, now our service is up and running. I'm just creating the channel now. Okay, you can see here, channel is getting created in the first, and after that it will get joined for both of the peer. And these are the scripts, so you have to just do this hands-on, so you will get a more idea. Right now I'm just trying to little faster, but what kind of doubts and everything you can always you can ask me, so we'll discuss and we'll get clarification. Okay, so channel creation is done, so we'll try to cover this, I mean, basic things from the CLI itself. So in the next section we will, again, don't worry, it's not something final. When we're talking about the APIs and all, I will explain the transaction flow from scratch, so you don't need to worry, even though some things are going little above you from your head. So I will explain, no worry, and I will get clarification of each and every doubt. Channel creation is done, deployment of the chain code. Okay, so let me just show you the basic chain code, two methods, so we'll be able to deploy it easily. Okay, this is the basic smart contract where let me just show you two methods only. Okay, first method is create contract. Okay, so what I'm doing, whatever the data I'm getting from the API, I'm just parsing it, and there is ID actually. Why I'm parsing? Because inside this data, it's a buffer format. So I'm just parsing it and converting into the JSON object. So agreement.id and putting this. So there are some methods available inside this interface, chain code stub, put state, get state, which actually generally do this putting data, creation of the read set and write set. So agreement.id, putting agreement data. So agreement data could be anything. It's a JSON object or a file or binary. So for particular ID, it records just key and value. So we are putting the same thing using create contract and get contract, the get data. Get asset by ID is nothing but getting data what particular ID. What I'm doing, context.stub.get state. Get state is again one more method in the interface which will get data for that particular ID from the CouchDB. So if you do not have, I'm just throwing an error. If it is there, I'm just converting into the string and just returning it. That's it. These two methods right now you were required, and we'll be utilizing this. Okay, this is the smart contract. Now let me show you the deploy chaincode.sh file. Okay, deploy chaincode.sh requires some kind of lifecycle chain code. Okay, initially from the top to bottom we can see chain code lifecycle. Let me just show you in a brief. Okay, okay, yeah, here the channel creation is done, right, up to here. Install chain code. Okay, installation of the chain code we have to do, and right now as community has added additional governance into the network, like we cannot directly install our chain code. We require sufficient approvals, and that can be considered. Right now default policy is the majority. Right now we have two organizations, majority of 2 is 2. Both of the organization need to approve the chain code, then only we can do the commitment of that chain code onto the network. Okay, let me just show you the steps now. Packaging the chain code is one of the steps. First, installing the chain code. I'm just installing both of the PS of the organization. I'm just checking query here, approving from organization one. So these are the different commands you guys can go through later on. I'm just checking whether this chain code is committed or not. It's ready to commit or not. If we get a sufficient approval, we'll definitely will be able to do it. If we did not have sufficient approval, then we won't be able to commit the chain code because it requires sufficient approvals. Again, after approving from the organization two, I'm doing the same thing. Commit chain code I'm checking the readiness, and I'm finally committing the chain code definition here. Once it is done, we can just invoke the transaction and finally query the transactions. Okay, these are the different chain code lifecycle we have to follow. Let me just deploy this now. Okay, first it will just execute from the top to bottom here. At the bottom, I just have everything. Pre-setup is nothing but, okay, one more thing. Pre-setup is the method where we'll just download the all the dependencies. Like in the chain code I have written in the JavaScript, right? So all the dependencies are there in the Node.js I have created. All the dependencies are there in the package.json file. So we have to install all the dependency, then only we can package it. So that's why we are doing first page is the installation, and that's why we will be able to see at the top some dependencies are getting installed actually here. Next one is the packaging the chain code. Before installation, we have to do the package. Once we done the package, we have to install all both of the required pair. We require both of the approvals of the organization. Once we get approvals, we can commit chain code definition. And finally, we can query, just check the chain code is committed or not properly. And the last step would be the doing some transaction querying it. So I'm just doing from this terminal itself right now. In the next video, we are going to do this integration blockchain explorer as well, and even from the API as well, I will show you. Okay, so I just added one data here. Let me just show you. I'm just commenting this, and we can add one more data here. We can see here, I created create contract. I just added random data. It's not something ID test, ID key is the ID 2, and test is the key, and value is the data. Okay, I'm just adding 3 now. Okay, and I'm invoking the transactions. I will just execute this method because these bottom methods are just commented. We can see chain code successfully invoked. Now I will show you this. All the services are up and running right already, and we have two cows DB. One cows DB is running. Where is it? Yeah, here. One cows DB is running on 5984. Okay, this cows DB 0 is running from the peer 0 organization 1. It's running on 5984. Let me show you that chain code now. So, okay, the admin username and the password of this is admin and admin PW. So make sure it's already there. We should not add this sensitive data into the file actually. So make sure you do it from the environmental variable later on. I'm just logging in. You can see different collection actually. This is the cows DB current state database I was talking, right? So this is the current state database. It's having a lot of other collections, and most of them are for internal use actually. And whatever the channel name and the chain code name you will have, the collection name would be exactly same. My channel is the channel name, agreement is the chain code. Right now I have. I'm just opening it. I just added this data, right? For 3 ID. Some indexes I already created indexes, but don't worry on this. So for 3 value, what is the data? Test is the data. Okay, right? So this is the how current state database looks like. Okay. Key and the value, we just store the data in the form of key and the value. Just okay. Now, we have executed most of the step creation of the network. First require certificate authority, require crypto material, we require policies in the form of artifacts. Now we can run all the services. And once we have these services, we can just create the medium for communication, and we can install the business logic. Once we have the business logic, we can initiate the business transaction here. So these are the different steps involved for creation of any kind of network. And these are the common actually. It's not something different. Every network will have exactly same steps. The business logic could be different, and your network topology could be different. As per that, um, you have to change or tweak little bit this configuration. Okay, so for this session, I think we are uh, good to close this actually. First we covered contract. First we covered core concept. Second, we have covered the network creation actually from the scratch. So these are the most important things actually. And next step, let me just open the agenda again. In the next video, next session, we will be covering this prerequisite, how we can do it. But I would highly recommend just follow the document and do the installation on your own, because that will save our time and we can utilize the time somewhere else actually. This virtual machine creations and all, I'm not going to do, because you can do these things on your own local machine itself. Creation, installations and everything. Okay. Up to here we have covered. So probably the next session will integrate this blockchain explorer. Even we can do write as well, but I think it's already more than 1.5 hours. So creation of the server and these things will be covered in the next session, and after that front end. Deployment will try to check if we time permits, we'll do it. Any questions till now? You can ask any question now.
Yes, Pawan. There are few questions.
Okay, let me just open.
The
Okay,
last
how many? Yes,
sorry,
sorry.
last unanswered question was from Vicky, if I require, can I join 1 lakh peer to the network?
1 lakh peers. Okay, no one has tried actually till now. 1 lakh, see, peer is just representing the organization. Why we require 1 lakh peer? That's my first question. Because peers, multiple peers is just for the high availability. Doesn't matter you have 2 peers or 1 lakh peer. One of the peer will be only endorsing the transaction, and it will be redundant, right? For keeping data with all this peer and syncing up continuously. It is, I mean, not recommended to have that many. I mean, 1 lakh peer. Even people prefer to have very limited number of peers on any organization.
Pawan, actually I asked because of if I am having many more organizations. Let us consider a scenario of I am having more than 500 organizations.
Okay,
Under
okay,
that, can I have
yes,
as
okay,
many
okay.
as yeah.
Okay, I got your question now. Maybe you are representing peer as an organization. Then in that case, I thought within the same organization you are asking to have a number of peers. Okay, see,
Yeah, like a
uh,
subset of organizations that has subset of peers.
okay, 1 lakh organization you mean to say in the form of peers. Say,
Uh, Go on.
yeah, see, so peers representing the organization. So within the organization, uh, 3, 4 peers are more than sufficient. But again, it depends totally on the use case, how many you want. So when we are talking about the supply chain application, there could be n number of organization, right? We don't know, even on the fly they can get onboarded. For one manufacturer, there could be thousands of suppliers who are supplying the goods. How we can onboard them? Practical, see, ideally they should have a separate organization and we should be able to manage it. Of course, there will be a lot of administrative overhead and all. But logically, just when we are thinking, they will never ready to pay you for the infrastructure. So it's manufacturer's responsibility how they wanted to handle the logical segregation at the API layer itself. Yeah, you can have maybe 10, 20, 30 organization, but increasing the administrative overhead, that will create a problems actually.
Got
Is that
you.
answer your question?
Yeah.
You can logically segregate possible because right now, even though ideally we think we thought like we will have this number of organization, but do really this all the organizations are going to pay for the infrastructure? What's just consider this two organization network setup. We require powerful machine, at least 16 GB of RAM, maybe 500 GB SSD. So that will cost us quite considerable actually. And there are a lot of other availability and reliabilities we have to do for our application, right? It will cost add a lot of cost actually. So it's better to have as minimalistic as possible.
Is there any other Hyperledger project that supports as much as organizations and the peers?
So other frameworks are built for some other use cases actually. It's everyone have different purpose. But logically, you can segregate on the Hyperledger Fabric. I'm not sure on the other. Ravi, do you have any opinion on the other framework?
Other framework, I mean,
They wanted to have 1 lakh organization, something like that.
so
I was just wondering like any other framework which see Hyperledger Fabric provide most of the flexibility. Even in other framework, you will not have this kind of flexibility, actual decentralized and the distribution. Other frameworks are something different actually.
So the one solution could be, it's very abstract idea, that combine these both idea, what we call hybrid networks. So what he's trying, his question is, or the problem he is that he wanted to set up, for example, a big scheme, something, a combination of
Yeah,
public
it's
and private
right.
network.
Not a combination of public and private network. It is entirely the private network. where it has as much as organizations under each organization there might be something between 4 to 7 peers.
Mhm. So I have no specific opinion for this particular practical
Say
case.
even this maintainer as well, they tried with like hundreds of organization or 500 of channels, not more than that. Even for hundreds of organization, even though they are considering, there are very few use cases who actually they are using, or maybe there is, I'm not sure whether it is there or not. 100 organizations as well in the industry.
Okay, so this is the limitation of private networks. You cannot
Yes, yeah.
scale too much uh, beyond some certain capacity or capability. Okay, so moving to next question from Nikhil. So Nikhil, is it possible for you to just ask
Yeah, directly. I
directly?
mean, will be
Yes,
fast. Yeah.
not Nikhil, Nihal. Sorry.
Nihal. Yeah, Nihal. Okay, you wanted to know about the volume sections in the Docker Compose. Okay. Okay, so Docker Compose, first of all, it's a tool for making life little easier. So if you're using directly Docker, you have to run one by one services. And we have multiple services within the same Docker. Single command can be used for running all the services. Okay. So volumes are used for mounting the data from our local machine to the inside the container. What I am doing here, from left side is the inside the container and right side is the local machine. Sorry, left side is the local machine and right side is the container. So inside the var slash hyperledger slash orderer msp, I am putting this left side data. Where it is, it's inside the channel crypto config ordering organization example.com order example.com and msp. This msp folder I'm putting inside this msp folder of the container, and it will get persisted in the sense, even though I am just doing docker compose down, we will be able to get this data on the local machine, right? So it will never get deleted until unless we are doing explicitly. So that's why this mounting generally we are doing for the certificate right now. I don't need to do again and again. So it will just pick automatically when this container start. It will put inside this. Put in the slide, like it will link, just link actually, virtual link it will create. And whatever operations we are doing, it will just reflect directly on the machine itself, this left side, this folder. Is that answer your question, Nihal?
Okay, let's move to the
Okay.
next question. Abhi has a question. Have you manually specified the code uh, channel config ML file?
Have you manually specified the code in channel? No, I did not get the question. Abhi, can you explain your question a little bit? Have you manually specified the code in? Okay, config. Yes, yes. See, if you have multiple organization, you have to put this all the code inside the config.yml file. Let me show you here. Here, right now at the top, we have two organizations, right? That's why organization one and organization two policies I have defined here. And as per that, you have to change the policies here. Or maybe if you wanted to add one more organization or two organization, you have to make the changes in this file. Definitely, we require that, because without that, this is the configuration policy box. Without, if you do not have, then you won't be able to do the operation later on. You will get errors.
Okay, so moving to next question from AM. Is it
What
possible
does
for you to?
Yeah,
Okay, you can answer
what
it.
does the different roles available in the HLF? So can you ask like what kind of roles you are saying? Peer roles you are saying, or user roles, or what exactly? You can ask directly. You can unmute yourself and ask. Okay. So when we're talking about the peer roles, there are four roles: endorsing, committing, leader, and anchor peer. Okay. So those roles are important, and generally when we are doing the transactions at different time of different time, peer plays different roles. When he is validating the transaction, it does the endorsements. Like first initially user invoke the transaction, right? He sent to the one of the peer will get the endorsement. During that phase, it act as an endorsing peer. Again, when okay, let me just show the transaction flow in a brief. Here you can see, right? This user is sending transaction to one of the peer will get endorsement from the other peer. This is the endorsement phase. Okay, and the peer will act as the endorsing peer. Again, this peer will send to the orderer will send data to the one of the leader peer actually, and organization will always have one of the leader peer, and this there is election process to get the leader peer, because to reducing the burden of this orderer, community has introduced this leader peer, and leader peer responsibility to broadcast this block to other peer in the organization. At that point of time, this peer is acting as a leader peer. And finally, committing peer. Once every peer get the block, they will just decode the block and validate every transaction, whether they have sufficient endorsements or not. And finally, that peer is acting as a committing peer. Okay. One more thing. Previously, when I'm sending the transaction, how I would know this peer is endorsing peer and all? For that purpose, uh, the anchor peer plays very important role. Anchor peer will uh, just get the data from the other peers and just let me just show you that there is a diagram, dedicated diagram. Here you can see here. This is the peer 0 from organization 1, and this is the peer 0 from organization 2, which is anchor peer. You just check in other organization how many peers are up and running, which is the anchor, the endorsing peers and all. He keep the data with him, and if user request, accordingly he will just send the data. In the 2.5, it got changed actually little. Now we don't need to send the transaction to each of the peer. We have to send the transaction to one of our organization peer. This peer will does everything. Peer gateway generally we have. This peer does everything for us. We don't need to worry on that part. So these are the different roles of the peers. Talking about the users, we have two roles: admin users and normal users. Okay. Another one thing, node organization unit. If you're talking, there are 4 node organization unit: peer, orderer, client, and admin. Okay. In their certificate, we'll have that information. Okay. What is the next question? Can we deploy a fabric network for a big hospital network for the company? Like, my doubt is, can we host a large scale network on the fabric? Yes, up to certain extent we can do it, but still, if you even though you wanted to have large, say this have a flexibility, you can just have a number of organization, but administrative overhead is, if it is increasing, so there is a possibility you may face some kind of complexities but syncing of the data and all if you are having more than 100 organizations and all. And again, so if you are hosting on the behalf of the organization, then just try if you can manage logical segregation and have sufficient organization only for the required hospital. So there is a Apollo hospital. You don't need to host all the different branches as a one organization, right? They could be one of the department in the same organization itself. You can segregate that data, something like that. Okay, I have enrolled the certificate.
This question got answered.
Okay.
That's the next one.
Okay, can we use another language for the bash?
Other than bash.
Okay, I think Vicky has answered, right? Argo bash. Yeah, sorry, arg bash. I'm not sure. Arg bash I never used, but bash. Okay. Doing this transaction you are saying, right? There are multiple, right? JSS, bash, terminal, normal terminal you can use. Anyone which is supporting the shell script, it's perfectly fine for you. Okay, system specification for basic fabric network. Yeah. So if you're doing on your local machine, I would recommend 16 GB of RAM, 500 of GB SSD, and 4 core at least. I mean, other application will be properly running in your case. This is the basic configuration I would recommend. But if you have 8 GB of RAM, maybe 500 GB SSD, and 2 core is also fine, but you may face some kind of laziness or maybe slow, you can say, like freezing the screen or something. But yeah, let's try. You can just check and let us know. Yeah, it's work on the WSL, but WSL will be very slow. Even you can directly try on the Windows as well, but Windows working is little different. So in the official documentation, they have provided some additional steps for the Windows installation. You can try it actually.
So there was
WSL.
also,
Yes, sorry.
there was also a question: was this code built up, or you use any template?
Okay, Fabric samples is the official official Fabric repository we have. So there are a lot of things. I will give a brief on the Fabric sample as well, how you can utilize for your use. Of course, I have taken a reference from there itself. I created my own everything then, the folder structures and everything. I generally follow this folder structure everywhere, like creating the YouTube videos and all. It's really it's simple, little easy actually. At the initial phase, probably you may feel it's new and little complex, but trust me, if you create a network 4 to 5 times, then you will be familiar with this, and it's really easy. Mac OS is also, I mean, on the Mac also, you can just replicate the same thing how we are doing on the Ubuntu. Ubuntu is straightforward. On the Windows, you can just try some additional steps are there. WSL also you can try, because we do not have a complex topology of the network, and definitely you will be able to do it on the WSL as well.
The question about system specification, to be very to bottom up approach could be that you use any of the machine if you bought that machine last 5 years, because you ask for a basic blockchain fabric network, and that will work essentially.
And this is Vicky, and I have one more question.
Yeah, please, Vicky.
I have seen Hyperledger can be used for finance sectors. The documents as it shows. If it is used in a banking sector where it has the main branch and few hundreds of sub branches, where under the sub branches there are thousands of bank addresses are there, which was used by the peers, then
Mhm.
how it could be ran as a system of
See,
network in Hyperledger Fabric. If I
okay, in
am
the
wrong,
banking, no, no, yeah, that's a good question. So in the banking sector, right, when you're talking about the SBI, even though you have 10 lakhs of different branches, doesn't mean you have to create a separate organization for them. There is a central authority for them as a bank itself. So SBI itself can represent as a organization, and if there is other bank, HDFC, they can have one more organization, but their department, their branches, they can manage like maybe role basis or something, some other approach, logically segregate them, because they don't require, right, they trust this SBI itself is the central authority for them for all the branches, and whatever the things are happening, it goes through their main branch itself, right, this SBI itself, who is admin, main admin, so they can represent it as a single branch itself. And trust me, the CBDC, central bank digital currency, I don't know how many of you are owning, but the government is using Hyperledger Fabric only for that. They have a lot of organization, a lot of peer as well, as per my understanding. But a lot of other countries as well, they are using Hyperledger Fabric for their CBDC, central bank digital currency.
and if it is the case, like under the SBI bank, as you said, as the SBI main branch, we can have multiples of peers, like lakhs and lakhs of peers. If I also have orders according to that, is it feasible for that?
No, no, orderer, see, purpose is totally different. You have to understand what is the problem you are trying to solve. You will not have this many peers, right? If SBI we are considering as a one organization, it can have 5, 10, maximum 15 peer, or it could be additional as well, but it's not something 1 lakh peer will have. See, these branches are not representing the peer. Peer is just for high availability and owning the smart contract and the ledger, not more than that. It is not actually segregating the your branches or maybe departments or something. That is
Okay.
actually a physical service which is representing actually organization indirectly.
Okay. So interest of time, what we had planned. So can you answer this last 2 questions about Docker and CouchDB are prerequisites for, I believe, for establishing or learning from this particular course?
Yes, yes. Docker basic is important. Just try to understand how this Docker Compose is working, and for running any kind of Docker container, what is required. See, basic things are more than sufficient. I already provided one resource, I think. YouTube channel, I segregated a couple of videos, but you can search on your own as well, like couple of hours, you will be able to familiar with the Docker and the JavaScript if you're not. That will be sufficient. And CouchDB don't require, no worry. CouchDB is just a service actually. If you are familiar with the Docker, that is more than sufficient. Accessing the CouchDB and all is not going to take. So it's getting used internally, so we don't need to worry anything. The peer will automatically create the CouchDB. I mean, add the data. We can just visualize it by logging into the system and just check the data. That should be sufficient.
Okay, the last question.
Okay, I have HLF network built using 2.3 version. Can I upgrade it to the okay 2.5? In the official documentation, I think they have already provided the script for the upgrades, right? I know 2.2 to 2.5 is there, but I need to check 2.3 to 2.5. It should be there again because there are no major changes from the 2.3 to 2.5. In the 2.5 only they introduced this they removed the system channels and all, right? So there should be happy official documentation for upgrading the chain code. Initially I did for 1.4 to 2.2, but recently I did not check. Probably I will just share that information in the next session. Did that answer your question? Yeah.
Okay, so that was the last question. So at the end, I would like to thank Pawan for really wonderful questions and all the participants who have been here for last 1.5 hours. And initially it will be, if you are already familiar with this whole process of establishing or using sample code, then it's that would be nice. And if not, then you have to spend few hours, at least 5-10 hours on this Linux and Bash commands, because after 5 or 7 or 10 hours, you will feel comfortable and you will be able to identify, okay, what is happening and what is good and what I have to do and how I have to do. So you have to bear with us, at least attend all these three sessions, so you have enough vocabulary to follow up after this after our events. So any final thoughts, Pawan, and then we'll wrap up. And
Yeah, thank you so much guys for joining this. I mean, till 2 hours we are here. I know you guys have more motivation to learn these things, and trust me, the hyperledger fabric, if you understand the basic core concept first and the transaction flow I will be explaining. So most of the fabric you already know, so you have to just apply your skills for any kind of POCs and all. So just try to understand and ask as many questions as you can. Even you can interrupt me during the session as well, so we'll have that context itself there and we can explain maybe in the more depth and all. And you guys can, you can ask your friends as well to join who really wanted to learn the Hyperledger fabric.
And after this meeting, I will kind of upload the video recording on the YouTube channel and on the LinkedIn. But actually, because it's on LinkedIn Live, so it will be always on that particular event page. And for the next session, which we schedule for next week, same time, and probably 10th March. No, sorry, 10th February from 10, and then we'll carry forward from there itself. So thank you everybody, and see you next week.
Thank you guys. Have a great day. Thank you, Ravi.
Thank you. Bye-bye.
Bye.